Assalamu alaikum. I want to talk about object-oriented design principles. What is object-oriented design? Is a programming language model organized around objects rather than actions and data rather than logic. Why we need object-oriented design? The programming challenge was seen as how to write the logic, not how to define the data. Object-oriented programming takes the view that what we really care about are the objects we want to manipulate rather than the logic required to manipulate them. So now after we understood the importance of OOP design, we should ask the following question. Is there a predetermined principles we can follow to build OOP designs? Yes. Encapsulation, it means enclose something or something in, or as if in a capsule, or express the essential features of something. Well, now in a nutshell, encapsulation is the hiding of data implementation by restricting access to accessors and mutators. We will define accessors and mutators. Accessors is a method that is used to ask an object about itself. These are usually in the form of properties which have under normal conditions a get method which is an accessor method. Mutators are public methods that are used to modify the state of an object while hiding the implementation of exactly how the data gets modified. So the use of mutators and accessors provides many advantages. By hiding the implementation of our person class, we can make changes to the person class without the worry that we are going to break other code that is using and calling the person class for information. Program to an interface, not an implementation. The second principle of OOP design, that is, first we need to understand the definition of an interface. Interface is a language construct that lets us define a set of methods and properties in it. Any class that implements this interface must provide an implementation of this interface. The value of interfaces. An interface distills the collaboration between objects. An interface is free from implementation details and it defines the vocabulary of the collaboration. Once I understand the interface, I understand most of the system. Why? Because once I understand all the interface, I should be able to understand the vocabulary of the program. We will continue. This principle is really about dependency relationships which have to be carefully managed in a large an app. It's easy to add a dependency on a class. Interestingly, the inverse isn't that easy, and getting rid of an unwanted dependency can be a real refactoring worker or even worse, block you from reusing the code in another context. Once you depend on interfaces only, you are decoupled from the implementation. That means the implementation can vary, and that's a healthy dependency relationships. And the open-closed principle is already mentioned by Bertrand. Software entities, classes, modules, functions should be open for extension but closed for modification. There are many heuristics associated with object-oriented design. For example, all member variables should be private, or global variables should be avoided, or using runtime type identification is dangerous. Jaskov said all systems change during their life cycles. This must be borne in mind when developing systems expected to last longer than the first version. We want to continue. They are open for extension. This means that the behavior of the module can be extended. They are closed for modification. The source code of such a module is inviolate. No one is allowed to make source code changes to it. Don't repeat yourself principle. Its principle states don't repeat the same logic in multiple places. This applies to everything you write, not just to copying entire applications. When you find yourself writing the same code in two or more places, it is time to refactor. Extract a method and put the duplicated code in that method. When the code is used by more than one application, extract the code into a function call that you put into a shared library. Continue. There are times when substantially similar code is just different enough that it needs to be duplicated. Consider the alternatives first thought. You will pay the price in increased maintenance, but at least you will be aware of what you are getting yourself into. Single responsibility principle. The context of the single responsibility principle, we define a responsibility to be a reason for change. If you can think of more than one motive for changing a class, then that class has more than one responsibility. The SRP is one of the simplest of the principles and one of the hardest to get right. Liskov substitution principle. This principle is complementary to the open-closed principle. It suggests that methods which use a certain class must be able to use its derived classes without even knowing them. A base class must be substitutable by its derived classes without the necessity of changing any code in the method using it. Let's be code example. Assume we need a square class. Clearly, a square is a rectangle, so the square class should be derived from the rectangle class. The programmer of the test LSP method made the reasonable assumption that changing the width of a rectangle leaves its height unchanged. Solutions cannot be viewed in isolation. They must also be viewed in terms of responsible assumptions that may be made by the users of the design. Continue in the next class.